Hi, I'm Stuart, one of the hardware engineers here at Cyrus, and I'm joined today by Nick Clark, Managing Director of Cyrus. Hi, Nick. I know you're very busy, so thanks for joining us.
Hi, Stuart. My pleasure, of course. Happy to be here.
So, Nick, today we're here to discuss the technical differences between vinyl and digital, the two formats. We're clearly seeing a comeback to vinyl, and one of the reasons for this is the fact that many vinyl fans make the case that their vinyl records sound better to them than digital sources. Can you expand on that?
Yeah, it's an interesting topic, and actually one that's usually generates some very hot debate amongst both camps. Analog versus digital. Obviously, analog is represented at most by vinyl these days, and digital by CD and now streaming. So there's also a bit of a comeback from compact cassette as well, but that's another discussion altogether. Both formats do have their strengths and weaknesses, as hopefully we can get into today. So if we start with vinyl, for example, things we can talk about are loudness and playing time, high and low frequency reproduction, and distortion and noise, and how indeed that in some cases can actually affect the running order of an album.
Okay, well, that is quite a long list, but can we start with loudness perhaps? And first of all, for those that are not familiar with this, let me just say that loudness is related to dynamic range, meaning the difference between the loudest and quietest part of a recording. So the higher the dynamic range, the more contrast there will be in a recording, and the more natural it will be. Unfortunately, digital music is very often mastered with a low dynamic range, and this has a lot to do with the way that music is consumed these days, meaning on cheap headphones or perhaps Bluetooth speakers. However, on better systems, these recordings will sound maybe flat and exaggerated, but the good news is vinyl doesn't lend itself to this easily. Is that correct, Nick?
In general terms, that is absolutely correct. Loudness has always been a challenge with cutting music onto vinyl, and whilst the trend has been towards, a bit of a loudness war and music that sounds as much as loud as possible, there are actually technical limitations of vinyl, which strangely enough help to reduce the effects of this so-called loudness war. The louder the signal is on vinyl, the more space it takes up on the groove. The larger the groove, the more space has to be used for the same length of a recording, and consequently you get less total time on the actual disc itself. So for vinyl releases, loudness actually has to be very carefully managed. By contrast, digital releases have no such restriction, which for some mastering engineers can be a bonus, but consequently many vinyl releases are mastered differently to the digital releases, and with high dynamic range they actually sound more pleasing to our ears.
Okay, but that's the case only when the records are mastered differently, and a digital dynamically compressed master is not used as the source for the vinyl.
Of course, at any time in any mastering process, regardless of format, it has to be handled carefully to get the best out of the format.
Okay, so there is a downside to dynamic range too. And the quieter the recording, the more surface noise kicks in, and that results in a reduced dynamic range. I mean, for example, vinyl overall is not particularly good at this parameter, achieving around about 77 dB, whereas, for example, CD is 96 dB.
Yes, of course, and this is actually one area where digital excels. You're right, vinyl can theoretically achieve around 77 dB. Traditional CD around 96 dB, and a typical high-res file can achieve potentially up to 144 dB. But then you obviously have quite a huge hardware challenge as well to realise that in the final output of the device.
Sure. So when the CD format was introduced, the engineers decided that 96 dB dynamic range would be adequate. Was that a wrong assumption?
Not by any means. In order to fully appreciate 144 dB recording, we'd actually have to damage our ears. Remember, dynamic range is about contrast, so you have to listen to a massively loud sound in order to not miss out on the low level detail that 144 dB would retain. And also don't forget your listening environment is not completely quiet, so any any information below the noise floor of your listening room would essentially be lost.
Okay, but it's not only dynamic range where digital has the cutting edge. Frequency response is another aspect?
I think so, yes. There are a few things to mention here. Let's start with the equalisation that I mentioned before. In order to compensate for the limitations of the media, an equalisation curve is applied. Typically the RIA curve is used, but other curves are available. This is a form of pre-emphasis, where at the low end of the spectrum a minus 20 dB cut is applied, but at the high end of the spectrum a plus 20 dB boost is applied. On the playback, a reverse curve is applied to the music and the original signal is theoretically recreated. This technique helps increase the available length of recording time by reducing the amount of space taken up on the vinyl by low frequencies. It also helps alleviate the problems that high frequencies and sibilants pose by filtering them out during playback. But as with any equalisation and re-equalisation, you're limited by analog component tolerances when trying to get the original sound back. This results, or can result, in added distortion and phase shift depending on the accuracy of the components used.
Okay, so may all of that account for the magic and warmth that many fans seem to point out with respect to vinyl?
Possibly, but there may be another factor that plays a role here. Challenges of high frequency reproduction. Modern digital recordings, unlike original tape, capture the whole audible range and with no roll-offs. And this can pose some problems when releasing on vinyl, as this media does struggle with high frequency ranges. One of these ranges is the 3 to 5K typical for sibilants. That's the beginning of the letter T and the end of the letter S. But it's also carrying important information for cymbals, brass and strings. These carry a lot of energy with them, especially when the RIA curve is applied. This means that a boost of 20 dB is given at the top end of the range, as I said. As a result, the stylus can struggle to keep up with the grooves as such movement in such a short time is required, and may eventually start skipping over some of them. To remedy the situation, the so-called DSs are used, and these remove some of the unwanted energy around his especially harsh sibilants. Whilst in theory this is unobtrusive, you are actually taking something away from the original recording, so there's undoubtedly an effect.
Okay, and what about high frequency roll-off?
In fact, some of the cutting factories do recommend filtering any content above 16 kilohertz when releasing on vinyl. If vinyl records are mastered from the analog sources, there's usually no content above 18 kilohertz anyway, so even CD digital files have a wider frequency response up to 22.05 kilohertz. Oh, and of course, higher sampling rates such as 192K offer up to 96 kilohertz, 384 offers up to 192 kilohertz reproduction.
Indeed. So theoretically, humans can hear up to 20 kilohertz, but there's not many of us that can actually reach that high. Plus, adding in the factor that hearing deteriorates with age, many of us would be lucky if we can actually hear 15 kilohertz.
Unfortunately, that's true, and sadly, that's something that comes to us all with age.
Yes.
But now let's turn to the bottom range, which as humans we have less problem with.
Yes.
Low frequencies actually pose different challenges for vinyl. The lowest bass at high volumes has to be avoided as it will use too much space on the record. Now, whilst the RIA curve we mentioned before does help with this, it's still good recommended practice to record the lowest bass in mono. Often recommended to cut out anything below 40 Hz and anything below 300 Hz should essentially be recorded in phase or mono. This compromise is still a significant change compared to the original recording. We have to remember that open bottom E string is actually 41 Hz.
Okay, but digital doesn't suffer from this at all, is that correct?
That's correct, yes. 20 Hz and below is absolutely no problem with digital, and most modern audiophile amps aim to almost DC reproduction.
Okay. So can we talk about channel separation, how vinyl fares with that?
Yeah, sure. First of all, we have to talk a little about how stereo imagery is reproduced. Both channels are cut into the same groove, so the only direction of the movement of the stylus is what creates the stereo image. Therefore, the mutual crosstalk between the channels is relatively high, leading with vinyl to a channel separation of typically 25 dB at 1 kHz.
And digital's better than that, of course.
Absolutely, digital processors can offer easily north of 90 dB or more.
Okay, and another kind of unique factor that can have an impact on the sound of vinyl is its reliance on a stable and accurate motor speed. Can you expand on that?
For sure. Vinyl is absolutely dependent on motor speed accuracy, and any imperfections in the turntable or disc will result in something called wow or flutter, which are time-related distortions. Where the belt or direct drive is used, variations may be detected. Now, high-end turntables will reduce this with extremely well-engineered and therefore expensive motors and drive systems, but even these are not immune to supply current variations. Even the placement of the hole on the record can affect the wow performance. Digital's unaffected by such problems. Specifically, we talked about CD, but streaming obviously has no mechanical element. But it does have its own unique timing issue of jitter, which is something that occurs in the digital domain, but also then causes analog distortions in what's finally reproduced. Another drawback of vinyl is rumble from the playback turntable's drive mechanism. If you recall the RIA de-emphasis curve that we were applying, that gives a 20 dB boost to the lowermost end of the spectrum. So any noise in this low frequency area will be greatly amplified. Again, a good high-end turntable design will greatly reduce this, but some phono stages, like Phono Signature, include special filters that can be switched in to reduce this unwanted rumble.
Okay, and then one final characteristic which is interesting about vinyl and that we haven't covered yet is the closer you get to the end of a side, the greater the distortion becomes.
Yeah, indeed. If you look at a vinyl record, that will rotate at a constant angular velocity. What that actually means is that the linear velocity changes. So at the outside of the record, you'll travel further for the same piece of music than on the inside of the record. What this means in practical terms is that the more condensed the sound's getting as you go into the middle of the record. And it's more difficult for the styles to then follow. Cutting factories have therefore recommended placing demanding, powerful tracks at the start of the record rather than the inside. Now, this can then have an effect on how an artist might order their tracks. For example, in the case of Peter Gabriel's So album, the track In Your Eyes, because it was a concept album, was always intended to be on the end of side 2. But the low bass frequencies in that track couldn't be properly reproduced, so it was actually moved to the beginning of side 1. So thus, the CD and the vinyl had a different running order. So, a compromise caused by the characteristics of the medium then caused the artist to record the record in a way that he hadn't originally intended.
Okay, so did that change the way in which the tracks were arranged on the vinyl album from the CD? I didn't realise that.
Yeah, it's quite interesting that something so subtle can cause such a big effect.
Okay, so in summary, it seems that on a technical basis, digital audio will always outperform vinyl, and therefore should deliver the best performance.
In a technical assessment, I guess you could say that's true. I mean, all digital formats can outperform vinyl in pure numbers. We should also bear in mind that a high-quality digital sound is generally more accessible to the end user. You can just buy a CD player or a streamer and pop your CD in or start streaming. There's no adjustments, there's nothing you've got to do. However, a well engineered and a well set up, vinyl system can still offer huge enjoyment and excellent reproduction to the end user. And I genuinely think there's a lot of life in the format yet. And frankly, here at Cyrus, however people enjoy their music, we're happy to give them the best possible experience.
Oh, excellent. Fascinating stuff. And thanks for the discussion. I think we've covered quite a lot today. If you could all let us know your thoughts in the comments below, we really appreciate it. And Nick, thanks once again for joining us.
Thanks, Stuart. Pleasure as always.